We have talked about graphing and we've talked about how we find the mean, median, and mode, and the standard deviation, and the variance, and the range, and all kinds of descriptive statistics for samples of data. Now we're going to talk about random variables. First, we need to know the difference between discrete and random variables. And I guess that involves knowing what a random variable is in general. So a random variable is a numerical measure of the outcome of a probability experiment. So its value is determined by chance. Random variables are typically denoted by capital letters. And usually we use a capital X. So we've talked about discrete and continuous variables before. The only difference now is that we're talking specifically about what a random variable is. So a discrete random variable has either a finite or a countable number of values. Countable being the important word here. Remember, things we count are discrete. So the values of a discrete random variable can be plotted on a number line with space between each point. And we'll look at how that works here in a minute. On the other hand, a continuous random variable has infinitely many values. And the values of a continuous random variable can be plotted on a number line in an uninterrupted fashion. And remember, continuous are things we measure. So let's look at a couple examples. We'll state whether the example is discrete or continuous, and then we'll graph the possible values on the number line. So the number of A's earned in a section of statistics with 15 students enrolled. Well, it's something we count, so that makes it discrete. And they can go 0 A's, 1, 2, all the way up to 15, right? So let's graph those values. So we could have 0, 1, 2, 3, 4, all the way up to 15. So if you notice, we're just putting a dot at every tick mark or counting number up to 15. Now the number line goes to 20, but there's no way to get more than 15 A's, right? Because there are only 15 students. Okay, our second example is the speed of the next car that passes a state trooper. Well, that's continuous, right? Because you could go 55 miles an hour, or you could be going 55.5 miles an hour. And we measure that with radar or with our speedometers. So that car technically can't be going 0 miles an hour or it wouldn't be passing a state trooper, right? But it could be going very slowly. So what we do is we put an open circle at 0, meaning it can't be that number, but it can be really, really close to 0. And then we shade. I guess I'm going to do this in a different color so we can see it better. we shade all the numbers it could be. Now, technically, it could go to infinity, but let's be honest, how fast can a car really go? I don't know. Some of those race cars go pretty fast. I don't know how fast they go. But for our purposes, we're just going to say it keeps going to infinity. All right, now that we've talked about the difference between graphing discrete and continuous random variables, let's talk about discrete probability distributions. So, for a discrete probability distribution, we need to do some vocabulary, of course, as always, and we need to talk about what rules they have to obey. So, the probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities. A probability distribution can be in the form of a table, in the form of a graph, or in the form of a mathematical formula. Mostly the ones we're going to look at are in the forms of either tables or graphs, and mostly tables. So the rules that they have to obey are the same as the rules that we've talked about before, and all probability distributions have to follow these rules. First of all, we have the sum of all the probabilities has to equal 1. That was true before when we talked about those contingency tables and probability tables and frequency tables, right? This is no different than a relative frequency table. And this next one that says 0 is less than or equal to p of x is less than or equal to 1 means that every probability in the distribution must be between 0 and 1 inclusive. And what that inclusive means is that it's allowed to equal 0 and it's allowed to equal 1. Now, normally when I am on ground, we take a pole and we make our frequency and probability table for a discrete probability distribution for the shoe sizes of the whole class. So the random variable x is the shoe size, and we're not going to distinguish between men's, women's, and children's just for simplicity's sake. And if you wear a half size round, we would round up to the next one just to make our lives simpler. So, since I don't have the class, I used a random number generator to get our values. So I had 0, 1, 3, 2, 2, 1, 2, 4, 0, 2, 2, 2, 2, 2. Now we have a lot of really large shoe sizes in this class, and not very many what I would call regular shoe sizes, but that's okay. This is what happens with a random number generator. So how do we find the probability? Well, remember, to find the probability, in this case, we take the frequency and divide it by the total number of observations. So I will tell you there should be 25 total observations. So for shoe size of 4, we had 0 of them, so that's 0 over 25, which equals 0. Then we have 1 over 25, which is 0.04. 3 over 25, which is 0.12. And we can just keep going, right? So you should finish filling in this table as I'm doing it. You can pause the video if you need to. In fact, I think to save time from you guys having to watch this, I'm going to pause this recording and finish filling in the table. Okay, I've finished filling in this table. Guess if you have to, you can hit pause and make sure you have all the numbers correct. Now, what did we say about a probability distribution? Every probability has to be between 0 and 1 inclusive, meaning it can equal 0 and it can equal 1 and it can equal anything in between them. So if we look down through here at our probabilities, that's true. And we should also check that the probabilities add up to be 1. So if you add all of these together, you will indeed get 1. And so it is a probability distribution because it meets the requirements we talked about above. Okay, we'll end this video here, and we will pick up with talking about graphing discrete probability distributions in the next video.